Welcome to lecture 43. I can say concluding lecture of course Signals and Systems. So actually the course was planned for 40 classes. We could extend for another 3 classes in order to accommodate more number of examples into the course. So in this session, we are covering the last part of Z transform, that is unilateral Z transform, and part of the things that we had left in the earlier session, that is inverse systems. So these two topics would complete the course Signals and Systems as well as your chapter Z transforms. So let me share my screen. In lecture 43, the last part of Z transform chapter 5, the topics covered are inverse systems, unilateral Z transforms, and concluding remarks on the course. So inverse system, in the previous class session, we just started it. So we could understand, like, we will have an example wherein you will be asked to find out the inverse system of the given system, and you are supposed to find whether it is causal or stable. Okay, so for example, think that I have a system called h of n. If its inverse response exists, we call it as h inv of n. When we convolve it, you know that you get it as a delta of n. This we have been studying from unit 2, right? So if I take it in the z domain or frequency domain, then h small h inverse of n, if it is taken in the z domain, it is represented as capital H inv of z. This is h of z. So convolution becomes multiplication, and z transform of delta n is 1. So this property we are extracting, we are utilizing. So h inverse can be found out by reciprocal of h of z. That's it. So if you're asked to find out inverse system, what you need to do is you need to find the system operator, take its inverse, take its ratio or reciprocal. You'll get the inverse system. So that is what we will do in the examples that we just take it down next. So here, when you call that a system is causal and stable, you call a particular system causal and stable both if the poles, all the poles should lie inside the unit circle. Unit circle means z is equal to 1, right? If with that radius we would have drawn it. To call a system to be causal as well as stable, all the poles should lie within the unit circle. Then only we can say that. So what is your work is, you will be asked to find out inverse system. So what you have to do is find out the poles, check where does the pole lie. If the poles are within one or within the unit circle, come to the conclusion that it is causal and stable, or else it is not causal and stable. That's it. That is what we need to do. Here's the first example I am taking. So here's the equation given, differential equation given. You need to find out transfer function as well as transfer function of inverse system. Okay, you need to find transfer function of inverse system. So how to do it? So here we go on. So y of n, when you take its z transform, we take it as a y of z minus this one. This can be written as y of, right, I can say, right, z inverse, because I have y of n minus 1 time shift property. This is y of z plus 1 by 4. Here this k value is 2. So z raised to minus 2 y of z. So this is how we write. So x of n means its z transform is x of z plus 1 by 4. Here n minus 1 is there. Hence I'll get, by time shift property, I'll get this term x of z minus 1 by 8. So here I get it as z raised to minus 2, because in the place of k I'm having 2 x of z. So now I take y of z common here. So if I take y of z common, what I get? 1 minus z inverse plus 1 by 4 z raised to minus 2. This is equal to, if I take x of z common, what is left? 1 plus 1 by 4 z inverse minus 1 by 8 z raised to minus 2. So therefore, h of z can be got by ratio of y of z and x of z. So y of z should be in the numerator. So this component coefficients come to the denominator. All right, 1 minus Z inverse plus 1 by 4 Z raised to minus 2. So this one as it is here, 1 by 8 Z raised to minus 2. Simple. So up till here it is half away. You have solved half the things. Now what we are supposed to do is you need to find out the factors of it. So factors, how to find it out? So I'll show one of this. I'll write it here. 1 plus 1 by 4 Z inverse 1 by minus 1 by 8 Z raised to minus 2 equal to 0. I need to find its factors. How to do it? So let us keep it simple. So I want to make it very simple. So what I do is I just multiply by 8z square. So what happens here? 8z square means I multiply by this means I should finally divide it by 1 by z. So this is what it means. It's like this. I'll take one more step for your analysis. So it is same factorization, but for simplicity I'm showing it here. So let us find out the factors. I'm not, you can say it as equal to 0 or not. So this I'll compensate it later. So now I concentrate on 8z square and this one. So if I take it inside, what happens? This will be left as it is. So here 8z square plus 2z minus 1, right? So this is what you get. So I'll solve for this. So to solve for this, I only solve this one. So what I get? I get it as 8z square into 1 is minus 8z square. So here 2z I need to get 4 and 2z, 4z and 2z will get me the value. 8z square plus 4z minus 2z minus 1. This is for simplicity, okay? 4z if I take common, I get it as 2z plus 1, 2z plus 1 minus 1 if I take a common, I get it as 2z plus 1. So you get 2z plus 1 as one factor and 4z minus 1 as one more factor, but this one, this quantity I need to take here. So 1 by 8z square. So I get it as, just carefully listen, 1 4z 8z square means 4z into 4z. 8z square means 4z into 4z. So what I do is I take it as 2z plus 1. 1 of the 4z I write it here. This is one of the factor. And for the other factor, 1 of the 4z I take it here. So that I can get it in terms of z inverse. So what I get? Take it inside 2z by 4z. So I can write it as uh, 1 second. So 8 here, I should get it as 8. Okay. For 1 here, I take it as 2 because I want to get it as 1. So 2z into 4z, 2 4s are 8, z into z is z square. So 2z by 2z is 1 plus 1 by 2 z inverse. This is the first factor. And here 1 minus 1 by 4 z inverse. This is the second factor. Similarly, you can do the denominator. Okay. So this is just I have shown how you should do it. You can even have the other ways of doing it. Okay. So hence I get the numerator as 1 plus 1 by 2 z inverse, and the next factor is 1 minus 1 by 4 z inverse. That's it. So denominator you can solve in the same manner. So let me write the answer directly here. So you get it as 1 minus 1 by 2 z inverse whole square. You get it as like this, a minus b whole square form. Okay, so a minus b whole square form, you get it in that fashion. So now I need to find H inverse of it. H inverse means write this in the numerator, this in the denominator. That's it. See, you remember this? I take the next slide. H inverse of Z is, so you get 1 minus 1 by 2 Z raised to minus 1 whole square in the numerator. So in the denominator what we get? So this one, 1 plus 1 by 2 Z inverse, 1 minus 1 by 4 Z inverse. 1 plus 1 by 2 Z inverse, 1 minus 1 by 4 Z inverse. These are the H inverse components. So what are the poles now? Because this is a denominator, this becomes the poles. What are the poles? So for this I get it as equated to 0. 1 plus 1 by 2 Z inverse equal to 0. So what you get? 1 by 2 Z inverse equal to minus 1. So this Z inverse is equal to minus 2. So Z is equal to Z is equal to minus 1 by 2. So with this I get the pole Z raised to Z equal to minus 1 by 2. So here if I equate it to 0, what I get? So 1 by 4 Z inverse is equal to 1, because if this goes to on the other side, minus 1, minus and minus cancel, so I get it as 1. Z inverse is equal to 4, Z is equal to plus 1 by 4. So these are the poles. These are the poles. So once you get the poles, just find out where does these pole exist. So this is a unit circle, Z is equal to 1. This is a unit circle. So where this exists here, minus 1 by 2. Where this exists further near to origin, 1 by 4. Both poles are inside unit circle. Hence, what's the conclusion? Hence, the inverse system is both causal and stable. That's the conclusion. Okay, very simple. This is what you need to do. Okay, so I hope there are no doubts. Next one. So here I have taken just a bit of other variety. I have not given difference equation, rather impulse response has been given. Now the same thing you need to do. Find inverse transfer function, check its stability and causality. So h of n is given like this. So let us go for the solution. H of z. Delta of n's z transform is 1. You know it. So that's why only 2 will come here. 5 by 2. What's the z transform of 1 by 2 raised to n u of n? In place of alpha, I'm having 1 by 2. So 1 divided by 1 minus, in place of alpha, I'm having 1 by 2 into z inverse. Minus 7 by 2 is taken out. So this one is minus 1 by 4. So 1 divided by 1 minus of minus 1 by 4 becomes plus 1 by 4 z inverse. This is h of z. Now I want it terms of factors of numerator and denominator, right? So numerator I'll be having some factors, denominator also I'll be having some factors. Like that, in that form I want. So what I do is I take, these two things, I'll combine here in this fashion. So these two things I multiply to this. So I get here first term plus 5 by 2. So here there is no denominator, so this denominator will be multiplied, minus 7 by 2. So here there is no denominator, only this will be multiplied. So the denominator becomes 1 minus 1 by 2 z inverse, 1 plus 1 by 4 z inverse. Next, denominator as it is here, 2 is kept out, so rest of the things I'll solve it. I open the bracket, I get this one, 1 plus 1 by 4 z inverse, so and so. So this I open the bracket, 5 by 2 plus 2 4s are 8, 5 by 8 z inverse minus 7 by 2 plus minus into minus plus 7 by 4 z inverse. Now I mark the similar terms like 2 by 4 is 1 by 2 z inverse. So z inverse components I have ticked it here. I have ticked it. And the constants I have marked it in this fashion. 2, 5 by 2 minus 7 by 2. 2 and 2 denominator is same. So 5 minus 7 is minus 2. Minus 2 divided by 2 is minus 1. 2 minus 1 is 1. So 2 constant is 1. And here this one ticked 1. 1 by 2, 5 by 8, 7 by 4 and minus 1. So the LCM of this is 8. So 2 4s are 1 8s are 2. So here 8 1s are and 4 2s are. So all these things will get it, and I get it as 15 by 8 Z inverse. So that I'll take it in the next slide. So I get it as 1 plus 15 by 8 Z inverse. This one is constants that we have analyzed. 15 by 8 Z inverse minus 1 by 4 Z raised to minus 2. Okay, so I'll take its factor. So 15 by 8 can be got as plus 2 minus 1 by 8. So plus 2 minus 1 by 8 will get me 2 into 1 by 8 will be 1 by 4. That is what I'm having. So I can write it in this fashion. 1 minus 1 by 8 Z inverse plus 2 Z inverse. It's a factor. So take common. I get it as 1 minus 1 by 8 Z inverse, 1 plus 2 Z inverse. So this is a numerator. This is a denominator. This is the transfer function of a system. Now this is a transfer function of system. Now transfer function of inverse system. Transfer function of inverse system, just reciprocate it. So h inverse of z is equal to 1 divided by h of z. So 1 minus 1 by 8 z inverse comes to the denominator. These things goes to the numerator. Now what is a pole here? So pole here is I can directly write it here. Z is equal to So or else I just 1 minus 1 by 8 Z inverse should be equated to 0. So this one goes to on the other side minus 1, minus minus cancels. I get it as 1 by 8 Z inverse equal to 1. So Z inverse is equal to 8. Z is equal to 1 by 8. This is a pole of the first one. So what is the pole here? Pole is Z is equal to minus 2 you get, because plus here minus 2 you get. So if I draw the unit circle, so this is Z is equal to 1 unit circle. 1 by 8 comes over here, minus 2 comes over here. So this is outside pole, right? So as this pole lies outside unit circle, what's the conclusion? Conclusion is hence inverse system is not causal and stable. It's not causal and stable. Any one it can be based on it. So here it is not causal and stable. That's what has been asked. We came to this conclusion. Okay. So these are the two varieties of inverse system. Now we will go to the next topic and the last topic of this course, unilateral Z transform. Bilateral Z transform means whatever we studied up till now. Means Z varies from, it can have the values from minus infinity to 0 as well as 0 to infinity. Whereas unilateral Z transform means only it exists from 0 to plus infinity. That's the meaning of unilateral Z transform. So Z transforms standard definition and unilateral Z transform standard definition varies in only one point. Here we were writing n is equal to minus infinity to plus infinity, but in unilateral Z transform we started from 0 to infinity, because it exists only in the positive cycle, x of n z raised to minus n. So why it is needed? The unilateral is also named as one-sided zt. Zt is evaluated by using portion of signal associated with n greater than or equal to 0. This is important. Okay, so this form of the Zt is appropriate for problem involving causal signals and LTI systems. Think that we are dealing with only causal systems and LTI systems. Causal system and LTI system needs only unilateral Z transform. So hence in that case we use unilateral Z transform. So what are the properties of the unilateral Z transform? The unilateral Z transform satisfies the same properties as of the bilateral Z transform. Bilateral Z transform is the that we studied till now. That's the meaning of bilateral Z transform. The properties are all same with only one exception, that is the time shift property. So only time shift property is varied or changed. Rest all of the properties same for unilateral as well as bilateral Z transform. Now we will analyze what is that change happening in the time shift property. Let W of n is equal to x of n minus 1. Let us assume this. Now in this case, I take it in this equation, standard definition, x of z is equal to summation n equal to 0 to infinity x of n z raised to minus n. So this x of n minus 1, I'll take it inside here, x of n minus 1. So here I substitute n equal to 0 first. What happens? X equal to 0 means x of minus 1 z raised to 0. Z raised to 0 is 1. So x of minus 1 comes over here plus summation from n is equal to 1 till infinity. I can write it as x of n minus 1 z raised to minus 1, because if I write n is equal to 1 here, n minus 1 minus 1 is x of 0. So from causal system, it will be a causal system. So this is a x of minus 1, n is equal to minus 1, whether it exists or not we don't know. If it exists, initial conditions should be specified. So based on that, whether it is 0 or not, we can decide it later. So hence we take out the negative components outside. N equal to negative components, I'll take it outside. This is how we need to do the unilateral Z transform. Okay, now this one I make the change of a variable. N minus 1 is equal to m. I write it as m, which can be made as m equal to 0 here, but n is equal to m plus 1. So I make it as m equal to 0. So wherever n I am having, I make it as m plus 1. So m plus 1 I make. So z raised to minus m written here, z raised to minus 1 taken out. So hence W of z for x of n minus 1 will get it as x of minus 1 plus z inverse x of z. So this is very important. This is a change. People confuse here in unilateral Z transform. You should be very much careful when there is a time shift property, and definitely this is the only difference. Means we are prone to ask only this question for you to test whether you are able to identify the difference that is happening in unilateral Z transform with that of bilateral Z transform. Okay, so we shall take some examples to solve it. So here, one more way, x of n minus k, any value if you get, this is a standard form. Let me write one of the example. So think that I'm having x of n minus 2. So how to write it? So this can be written as, if I take its Z transform, I call it as W of n. So its Z transform, W of Z can be written as, so it is shifted by 2 times, right? So how I write it? Just check. X of minus 2, because I start from here. Minus 2, this will happen, see here. This will happen, see, x of minus 1, when I substitute n equal to 0, n equal to 0 here, I get x of minus 1. Z raised to 0 is it gone, it is 1. So x of minus 1 I get. So if it was minus 2, when I substitute n is equal to 0, I would have got x of minus 2 here, z raised to 0. So x of minus 2 component would have arrived. So that's why I start from x of minus 2 here. This is a standard definition. Okay, so x of minus 2, so here I wrote, plus x of, here minus 2 plus 1 means what? Minus 2 plus 1 is minus 1, that is z inverse, plus, I have already written this here, same this is generalized expression, I have already written the same thing here. So the next is this one, because k value is 2, minus 2 plus 1, I wrote it here. So this one, z raised to, k value is minus 2, x of z. So this is x of n minus 2. Similarly, if I ask you to write x of n minus 3, how would you write? If I represent it as w of n, if I take its zt, what I get? W of z is equal to, I write it quickly here, uh, x of minus 3, then plus x of minus 2, z inverse, plus x of minus 1, z raised to minus 2, plus z raised to minus 3, capital X of z. This is how we write when it is shifted. Similarly, it can be shown with a definition that x of n plus k can be written in this form. So here what we are trying is, both time shift properties correspond to bilateral time shift property with additional terms that accounts for values of sequence that are shifted into or out of the non-negative time portions of the signal. It is same as bilateral. What is the change? We are just taking out the samples, taking out these samples which are for n negative value. When n is at negative value, that components, that values have been taken out, because who knows, its initial condition might be 0. So that's why we are on safer side, keeping it outside. Now here x of z is there. This is perfectly unilateral Z transform. We can apply for it because it exists only in the positive axis. So this is the format we follow. We shall take one or two examples so that we can understand it. So x of n is equal to alpha raised to n u of n. You need to apply unilateral Z transform for it. Standard definition is x of z is equal to summation n is equal to 0, not minus infinity, 0 to infinity, alpha raised to n, u of n, z raised to minus n. So u of n, this matches, so no need to write it. N is equal to 0 till infinity. I can write alpha z raised to minus 1 raised to n. So this can be written as 1 divided by 1 minus alpha z inverse. That's it. Same as bilateral. There is no difference, because when it is u of n is written, it is same as bilateral. Now next one. See, here you should be very careful, because x of n is given with some value, but y of n is the time shifted version of x of n. Here you should be very careful. First what I do is I take x of z. What is x of z? It is 1 divided by 1 minus alpha raised to z inverse. That is what we just now analyzed. Now we have been given y of n is equal to x of n minus 2. So what we have to do? Standard definition, y of z is equal to summation n is equal to 0 till infinity x of n minus 2 z inverse of n. So when I substitute n equal to 0, what I get? X of minus 2 I get. I take it. So n equal to 0, z raised to 0 is 1 plus. Now when I substitute n equal to 1, what happens? 1 minus 2 is x of minus 1. N is substituted with 1. So z raised to minus 1. Now when I substitute n equal to 2, what happens? X of 0 comes. x of 0 comes from there. It is uh, I can say unilateral Z transform. So n equal to 2. So hence I substitute n equal to 2 here, z raised to minus 2, and then thereafter it is same as unilateral Z transform. So that's why I just write it as x of z. So this is your y of z. I know what is x of z. So substitute and do it. So here y of z is equal to x of minus 2. X of minus 2 means n value is minus 2. Substitute n value as minus 2. So alpha raised to minus 2 plus n value as minus 1. Alpha raised to minus 1, z raised to minus 1 plus z raised to minus 2. What is x of z? X of z is here. 1 divided by 1 minus alpha z inverse. So this is the answer. Slight variation in the unilateral Z transform. It is same as the bilateral Z transform itself. Okay, should be very careful about it here. Now, the last kind of the problem in this section, this topic, last kind of the problem. Okay, and I can say definite question also. One of the definite question will appear from this. Consider taking the unilateral Z transform of both sides of the difference equation. So this is a difference equation. Take the unilateral Z transform. Now, there will be a time shift property here. Time shift property, there is an exception for unilateral Z transform. There you should be very careful. Okay. So A of Z is nothing but summation k equal to 0 ak z inverse. It is standard for standard equation for the right hand side. This is standard equation for left hand side. But there exists one more variable or one more term. This arises because unilateral Z transform introduces few terms for which n is having negative values. So that term we will be representing with c of z. So a of z, y of z plus c of z is equal to bz, x of z. So y of z is equal to, so what I do is this p of z, so I just take the c of z on the other side. So a of z is divided like this. So wherever you have input force, this is input force, right? So we call it as forced response. Wherever you have no input forced, you will call it as natural response. So no input, we call it as natural response. Here input is forced, input exist. So hence we call it as forced response. We represent forced response as YF, natural response as YN. So we shall take an example to understand it. Understand this very carefully. Determine the forced response YF of n, natural response Yn of n, and output Y of n of the system described by difference equation. Difference equation is given here. Input is given here. Initial conditions are given. See here. Y of minus 1 is equal to 2. Wherever you get y of minus 1, substitute with 2. This is the initial condition. Okay. So with this we shall begin. So this one, I take the Z transform, unilateral Z transform. What I can write? Y of Z, wherever I have y of n, because it is a causal system. It is having only n greater than or equal to 0 values. Plus 3. How to write this y of n minus 1? I just rewind you the process. N minus 2, n minus 1, how it is written? X of minus 1 plus z inverse x of z. Same thing, I'll show it. I'll take it here. So y of n minus 1 can be written as y of minus 1 plus z inverse y of z. This is the difference in the unilateral Z transform. Rest everything is same. Okay. This is equal to x of capital X of z plus here same thing. I can write it as x of minus 1 plus z inverse x of z. That's it. This step is the important step. I star mark it. Rest everywhere it is simple. Y of z plus 3 into, what is y of minus 1? Refer the initial condition. It is 2. 2 plus z inverse y of z. This is equal to x of z plus x of minus 1. So x of minus 1, initial condition is not specified, and here x of n is u of n. U of n means it exists only for n equal to greater than or equal to 0. This is n equal to less than 0. So u of n does not exist. Hence it is 0 plus Z inverse x of z. That's it. Very simple. Now I write it as y of z plus 6 plus z inverse y of z. So this term is itself, I was representing it as c of z in the previous slide, generalized expression. This is equal to x of z plus z inverse x of z. Now take y of z common. What do you get? Y of z, if I take common, I get it as 1 plus z inverse. 1 here, z inverse here, plus 6 is left out. X of z, you take it common. So what you get? 1 plus z inverse. You get it in this fashion. Now what we are supposed to do? So this is in the, as shown in the previous case. So I get in this form. Az, yz, cz plus cz, bz, xz. Az, this is az, this is cz, this is bz. So what, how I want it to have, I want it to have in this fashion. Yz I want to take separate. I want to write it in this fashion. So I want to take yz separate, means I take y of z 1 plus z inverse on the left hand side. This I take it on the other side. Minus 6 plus x of z. I write it in this fashion. 1 plus z inverse x of z. I write it in this fashion, just to have a clarity. So I want y of z is equal to this one. I take it on the other side. I get it as minus 6 divided by 1 plus z inverse plus 1 plus z inverse divided by 1 plus z inverse. Right? 1 plus z inverse into x of z. So I got two terms. So when I got two terms, 1 second. Here I think somewhere I have missed. See here, 3. 3 into 2 is 6. 3 into here I have missed it. So 3 I should have written. 3 I should have written. 3 should be written here. Is it here? Yeah, it is here. 3. 1 plus z inverse divided by 1 plus 3z inverse. Okay, so this is also here. 3z inverse. So this is called, there is no input, hence we call it as natural response. This is called, there is input, hence we call it as forced response. Forced response. Simple. Now we take in the next slide. I take in the next slide. So given, what is given for us? We have been given that x of n is 1 by 2 raised to n u of n. What is its zt pair, unilateral Z transform? It is x of z is equal to 1 divided by 1 minus 1 by 2 z inverse. There is no difference, right? I write it as it is. Now I put it in the equation that we just now derived. Y of z is equal to see minus 6, this one as it is I write minus 6 divided by 1 plus 3 z inverse. This is without input. I call it as natural response, plus I want to substitute this 1 plus z inverse divided by 1 plus 3 z inverse x of z. 1 plus z inverse 1 plus 3z inverse. In place of x of z, I write this one 1 divided by 1 minus 1 by 2 z inverse. So I call this as y, capital Y, n of z. I call this as capital Y, f of z. Okay, so I try to solve it separately. This is straightforward. No need to, there is no much difficulty in solving it. If I take its inverse Z transform, I can easily write it. Expression. So let me write it. Y n of z. If I take its inverse Z transform, I get y n of n as, so minus 6 taken out. So plus is there, hence minus 3 raised to n u of n. This is natural response. Next, forced response. Forced response is written as capital Y f of z. If I want to take its inverse, what I have to do is this. I have to take it in this fashion. Numerator 1 plus z inverse divided by 1 plus 3 z inverse 1 minus 1 by 2 z inverse. You need to take its partial fraction. So you should use the partial fraction 1 plus 3 z inverse. So this will be asked for 10 mark questions if it is asked. Okay, because this is a solving take a lot of time. So by solve the partial fractions by yourselves. Partial fractions. So results in, it will result in, so I avoid repetitive work. A is equal to 4 by 7 and B is equal to 3 by 7. This is the answer we get once you solve it. So therefore, capital Y f of z is equal to 4 by 7 divided by 1 plus 3 z inverse plus 3 by 7 1 minus 1 by 2 z inverse. Very simple. Now if I take its inverse zt, what I get? Y. So what I wrote here, it is f. Okay. Y f of n is equal to 4 by 7 taken out. So here plus is there, hence minus 3 raised to n u of n. This is the first term, plus 3 by 7, minus is there, hence I should write just plus 1 by 2 raised to n u of n. So this is forced response. This is natural response. I call it as equation 1. I call it as equation 2. Now I have been asked to find out complete response. Complete response is addition of natural response and forced response. So that I'll do it now. So complete response, complete solution or response is y of n is equal to y f of n plus y n of n. So y of f of n, we just now solved it, 4 by 7 minus 3 raised to n. U of n, let me write it later, plus 3 by 7, 1 by 2 raised to n, plus this is what I wrote, and here it is minus 6, minus 3 raised to n, whole raised to u of n. So this is your complete response. This completes your problem. Now I have two more such variations. Okay, quickly solve it. Use the unilateral Z transform to determine forced response, natural response, complete response, given the difference equation and initial conditions. The given equation is y of n, I change the ink. This is y of n minus 1 by 9, y of n minus 2 is equal to x of n minus 1. This is initial condition. These two are initial conditions. X of n is equal to 2 into u of n. Very first thing is take what is x of z, because it is simple. 2 into u of n can be written as 2 into 1 raised to n u of n. It can be written in this fashion. So 2 is taken out. Take its zt. 1 divided by 1 minus 1 into z inverse. 1 can be skipped. Okay. So this is x of z. Next, difference equation. Y in place of y of n, I write y of z by taking its zt. Minus 1 by 9 can be written as, this can be written as y of minus 2. Y of minus 2 is 0, so I don't write it. Y of minus 1, z raised to minus 1. That I have written here. Y of minus 1 is given as 1. So hence 1 into y of minus 1 is 1 into z raised to minus 1 is z raised to minus 1. Then z raised to minus 2, y of z. So directly I have written here. I'll show it here. Its zt can be written as y of minus 2 plus z inverse y of minus 1 plus z raised to minus 2 capital Y of z. So initial condition says that y of minus 2 is 0, and initial conditions of this z inverse y of minus 1 is 1. So hence only z inverse plus this is as it is, z raised to minus 2 y of z. So same thing I have written here in this fashion. So here x of n minus 1 can be written as x of minus 1, but x of minus 1 does not exist because here it is u of n. So 0, it is leave it. What is left? Z inverse x of z. Now take x of z, y of z common. Y of z I take it common. 1 minus 1 by 9 z raised to minus 2 plus this minus 1 by 9 z inverse has been taken on the other side. That's why it became plus. This is like cz plus z inverse of x of z. Take this on the denominator. You get it as 1 by 9 z inverse divided by 1 minus 1 by 9 z inverse square plus z inverse x of z 1 minus 1 by 9 z inverse square. So here which is forced response and which is natural response? Natural response is the one which is not without input. Input is here. If input is here, this is forced response, this is natural response. So natural response is represented as yn of z. Forced response is represented as yf of z, because forced, this is x of z is forced here. Now I'll take it in the next slide. Natural response is this one. So of course your numerator also has the factors, hence you need to go for partial fractions. Go for partial fractions. So using partial fraction, I don't solve all the partial fractions because it will be a repetitive work. Using partial fraction method, you get 1 by 6 divided by 1 minus 1 by 3 z inverse minus 1 by 6 divided by 1 plus 3 z inverse. So you have to solve it by yourself for partial fractions, and you get a as 1 by 6, b as minus 1 by 6, and write it your natural response in this manner. So for that you get, and don't go for time shift property here, because time shift property of bilateral Z transform and unilateral Z transform is very different. There is a Z inverse component you can directly take, and so that is bit difficult, so don't go for it. And here you can observe the denominator factor is Z raised to minus 2. It's a quadratic equation, so you need to find its factors in terms of Z raised to minus 1. So that's why you get the partial fractions in here. So 1 by 6, 1 by 1 minus 1 by 3 Z inverse can be written as 1 by 3 raised to n. Here plus is there, that's why minus 1 by 3 raised to n. 1 by 6 is taken common, u of n. This is the natural response. Now regarding forced response, in previous slide content I have taken here. This is the y of z, previous slide. This is x of z, previous slide. Now I take the forced response here, this component. This component can be written using partial fractions again. Take its partial fractions. See, I'll show you. 1 minus 1 by 9 z inverse z inverse square can be written as 1 minus 1 by z inverse 1 plus 1 by 3 z inverse. Same thing I am having here and here. This x of z is contributing this factor 1 minus z inverse, that is here. Okay, so from here I've taken it here, and this thing will contribute these two factors, and by taking its partial fractions, a value is 9 by 4, b value is minus 3 by 4, and c value is minus 3 by 2. This is a partial fraction answer. So if I take its inverse, what I get? 9 by 4, and 1 is here, so you can either write it or skip it, it doesn't matter, you can just write u of n. Minus 3 by 4, plus is here, that's why minus 1 by 3 raised to n, and here minus 3 by 2, minus is there, 1 by 3 raised to n, whole is equal to u of n. Now for complete response, you have to write you have to add this as well as this one. This I call it as equation 1, this I call it as equation 2. So when I add it, I get this is a forced response and this is a natural response. That totally will result in complete response. Okay, the problem looks big, but it is simple. So next one, similar problem I have taken, the last one. What is x of z? Here it is minus is given, so hence 1 divided by 1 plus 1 by 2 z inverse. Okay, initial condition is here. So I take its z transform yz here. So this can be written as y of minus 1. Y of minus 1 is 1. So hence 1 plus z inverse y of z. So 1 by 3 is multiplied equal to 2 into x of z. So y of z is taken out. So 1 minus 1 by 3 z inverse equal to 1 by 3. This 1 by 3 I am taking on the other side. So y of z is equal to 1 by 3 divided by so and so plus 2 by 2 into 1 by this component on the denominator into x of z. This is natural response. This is forced response. Natural. This is forced. Okay. Now I take it in the next slide. Natural response, directly take its inverse Z transform 1 by 3 raised to n u of n. No partial fraction needed because denominator is a factor of, order is 1. Here it is just 1. So I can directly take forced response. Forced response, you just hear x of z is 1 plus 1 by 2 z inverse. So that gets multiplied to this. There are two factors. Hence you need to take partial fractions. So applying partial fractions, we get it as a equal to 6 by 5 and b equal to 4 by 5. So complete response, so this one forced response inverse zt. So here plus is there, that's why minus 1 by 2. Here minus is there, that's why 1 by 3 raised to n u of n. So complete response, when I add these two things, 6 by 5 minus 1 by 2 raised to n plus, here 1 by 3 component is here also and 1 by 3 component here also. I need to add these two things. So means 1 by 3 plus 4 by 5. I need to add these two things. So denominator I multiply 15. So 5 plus 4 3s are 12. So you get as 17 by 17 by 15. So that is what is written here. So this is the complete response. Okay, so I have few assignments. You can solve it by yourself. Same question. So first one, solve it by yourself. Second one, I think this I solved it or not. Did I solve the same thing? I don't know. So if it is solved already, you can solve B and C. So solve these all three things. So here you should be very careful. So x of n is given in this manner. So I give hint here, hint for this. So x of n is given in this manner. So x of n can be written as minus 100, 1 raised to n or n minus 11. It does not make any difference because 1 raised to anything will result in 1, right? So u of n minus 1. So here I can write it as minus 100 x of z minus 100 z raised to minus 11 divided by 1 minus 1 minus z raised to minus 1. So this is a hint. With this hint, you find out the complete solution. Fine. So this completes your course, your chapter Z transform, as well as your course signals and systems. So we had taken the slide in the very first class regarding course outcomes. So this is, you know, after learning the subject, whole of the subject, what all things a student will able to do. At the end of this course, the student will be able to analyze different types of signals. I think in the unit 1 you learnt about analyzing different types of signals, exponential signal, sinusoidal signal, complex sinusoidal signal, all those things, systems and its properties. So you are able to achieve the course outcome number 1. Number 2, analyze the time domain signals and solve for system response. So difference equations, convolutions, block diagram, all those things we studied. In CO3, it will attain analyze the frequency domain signals. So frequency domain signals, FS, FT, DTFT, DTFS, properties, all those things. So CO4 is all about relating different Fourier representation like FT to FS relation, DTFT to DTFS relation, and all those things, and apply it to various application, for various application like sampling, aliasing, okay, and reconstruction. So those are the applications we studied in the unit 4. Then in unit 5, apply the Z transform to analyze discrete time signals and systems. That is what we studied. Okay. So all course outcomes we were successfully met, and the signals and system course acts as a prerequisite for the courses analog and digital communications which you have in the 4th semester. Digital signal processing, very important subject which can fetch you very wonderful jobs. That you will be studying in 5th semester, I guess. Then some of the other courses you can get it in terms of elective are computer vision and digital image processing, very interesting subject. Digital signal compression, speech processing, multimedia communication, discrete wavelet transform. All these subject needs strong basics of signals and systems. Okay, so with this I conclude my today's lecture. Thank you for your patience listening and following all the courses of signals and systems. Thank you.